Good day, this is Mr. Morales, and these are your day 25 notes on graphing rational functions. So I went back and reviewed this assignment a couple of times, and I think I can give you a pretty concise and condensed version of this lesson. So here in the front, we have some things we need to fill in. What is a rational function? It's a function where you have basically one polynomial equation divided by another polynomial equation. And as long as the bottom one doesn't ever equal 0, you can actually apply the following steps. Now here we have a list of steps 1 through 5 with the possible next 6 parts on how we're going to do today's process. I am going to keep referring to these steps, so I'm not going to go through all of them right now until I begin the problems, because reading them alone doesn't really make any sense until you have experience with them in a problem. What is new though is that some of our graphs might have what's called a hole. And the hole in a graph is determined by any common factors you might have between a numerator and a denominator. So let's see, this little phrase here, and we'll get into that when it becomes important, because it's not going to happen in every problem that we review. So let's go ahead and talk about how we're going to graph rational functions. So there's a couple of key characteristics we're going to work on identifying first, and we need all these different characteristics in order to get an accurate graph. So the first thing we're asked to find is the x-intercept. Step 1 says, if possible, simplify your function. This function is already in simplest form, so step 1 is done. Step 2 says, find the x-intercept by setting the numerator equal to 0. So to get my x-intercept, I'm going to set my numerator equal to 0. Well, what number minus 4 would give me a 0? If x was a positive 4. So that means when x is positive 4, I'll have a 0 for my y value, and that's an x-intercept because it's on the x-axis. So I'll go ahead and put a point there. Next, to find the vertical intercept, a step above tells us that to find the vertical asymptote, you set the denominator equal to 0. So to get my vertical asymptote, I'm going to set my denominator, x plus 4, equal to 0. What number plus 4 would equal 0? Well, that would be negative 4. So the line x equals negative 4 is one of my asymptotes, and I'll go ahead and create that line right now. Let me go ahead and just change my settings really quick. So at x equals negative 4, negative 1, 2, 3, negative 4, I'll go ahead and make a dash asymptote line. This acts as my boundary for my graph. Now, going back to my horizontal asymptote. To get the horizontal asymptote, it says use the rules below. So what you have to do is look at your exponents for your x values. Both of my x values in the numerator and denominator have an exponent of 1. That means the top exponent for the function p is equal to the bottom exponent q. And we have a rule above that tells us when p and q are of equal degree, because degree just means what number you have for your exponent. So since they both have 1s, or they're equal, then we're going to go ahead and get our y equation, or our y line, by dividing the leading coefficients of both. Leading coefficients is the number in front of x's. So in order to get my horizontal asymptote, I'm going to have to take the leading coefficient of x to the first power, which is 1, so I have 1x to the first power, divided by the one that's right there on the bottom. 1 divided by 1 equals 1. So that means I have a horizontal asymptote at y equals positive 1. So I'll go ahead and create my line for that one as well. So I go to positive 1. Here's my other asymptote. All right, so now I'm going to go ahead and fill in my graph. Well, I know that I have to have a curve that goes through this intercept right here. So my curve will slide up and go something like this for the most part. So that means my opposite curve has to be diagonally opposite from it, and it basically is this line here. So there is our first graph. Now, do we have any holes? A hole is indicated when you have a common factor in the numerator and denominator. X minus 4 and x plus 4 are already simplified and they have no common factors. So then there is not a hole here, or there's none. Your domain, now this graph does go forever in both directions. The only time it's not equal to anything is when we set it equal to negative 4 in the x value. And the range also goes up and down forever, except at the one point where it's equal to positive 1. So basically the asymptotes are the two places where your graphs don't have a domain and or a range. All right, so let's continue this process again and explore some more. So number 2, we'll begin all over again from the very beginning. So first we're asked to simplify whenever possible. There's nothing to simplify here, so let's go ahead and move on to the next piece, which is to find the x-intercept. To find my x, whoops, I keep forgetting to lock this down. To get my x-intercept, I have to set the numerator equal to 0. If I solve that, I get plus 6, 2x equals 6 divided by 2, and I'll get x equals 3. So that means when x is equal to 3, my y value is 0 because that's an x-intercept. So there's my point right there. To get my vertical intercept now, what I'm going to have to do is set my denominator equal to 0. What number minus 1 would give you a 0? Well, that would be a positive 1. So at x equals positive 1 is my first asymptote. I'll graph them in just a second after I get my horizontal asymptote. So now let's look at the horizontal asymptote. We have to look at the exponents now. Don't forget that. Well, I have x to the first and x to the first. They have the same exponent. That means I have to use the leading coefficients, the number in front of the x's. So I'm going to take the leading coefficient of my top, which is 2, the leading coefficient of the bottom, which is 1, and 2 divided by 1 is 2. So there is my horizontal asymptote now. So now I'll go ahead and create both of those asymptotes on my graph. So at x equals positive 1, we're going to have a horizontal asymptote. It's the graph, the line that goes through, positive 1. I'm going to take off that straight mark I made. And then we have another horizontal asymptote at y equals positive 2. All right, and now we can go ahead and create our graph. We have an intercept here, so we have to have a piece of graph that goes down here. And then I have to have the other graph then diagonally across up here in this second quadrant area. All right, do we have any holes? Well, there are no common factors, so no, we do not. Our domain is every x value except when x equals positive 1, and our range is every y value except when y equals positive 2, the asymptotes, because those graphs never make contact at that point. Going on, let's do this again. Number 3. I'm going to go ahead and factor now. I have to simplify the numerator. It's a perfect square. So that would be x plus 1 times x minus 1. In the denominator, I have an x minus 1. And there's already a red flag now. I see that I have some common factors. I'm not going to scratch them out for a very particular reason that we'll find out in just a few moments. So let's go on now. To find my x-intercept, well actually, so what remains here is just x plus 1. To get my x-intercept, I set what remains equal to 0. So x plus 1 equals 0. What number plus 1 would equal a 0? Well, x would have to be a negative 1. So when x equals negative 1, I have a 0 value, or an x-intercept. And that would be at this point right here. Now let's go on and look for vertical asymptote. To get a vertical asymptote, you have to have a denominator. This does not have a denominator. If I really wanted to make an argument, I could say, okay, put it over 1. But I cannot make 1 equal to 0. It's a totally different number. So because I can't turn that denominator, which doesn't exist, into a 0, then I have no vertical asymptote. To get a horizontal asymptote, I have to look at the original exponents in the equation. I had a top exponent of 2, a bottom exponent of 1. 2 is greater than 1. That means the P equation is greater than the Q equation. And according to our notes, and it's our first note up here, if the P equation is greater than the Q equation, then we have no horizontal asymptote. So we have no asymptote for this one as well. No asymptotes give away what kind of graph we're going to end up with. Do we have a hole? Well, we have to ask ourselves, were there any common factors? And yes, there was. To identify the hole, we have to find the common factor, identify it, and then equal it to 0. So what number minus 1 would equal a 0? Well, x would have to equal then a positive 1. So for the hole, I'm going to have an x value of positive 1. but I need to get the y value. So you take this x value that you just found and you plug it back into the remaining equation that we had from the beginning when we simplified. So if I plug in a 1 for x and then I add 1, like it says right here, I get 1 plus 1, which equals 2. So at 1, 2, 1 comma 2, I have a whole. All right, so I have no other information. There's only one kind of graph that goes through 2 points directly and has no asymptotes, and that would be a straight line. But remember, our straight line does not connect in that hole. It exists everywhere before and after the hole. So what is the domain and range then? Well, this line is every single x value except at the hole, which is at positive 1 for the x. And the range is at every y value except at the hole, which is positive 2 for the y. So otherwise, it's all real numbers except for those 2 spots. All right, let's go on to number 4 now. And we'll repeat the process once again. First of all, let's simplify whenever possible. My numerator cannot be simplified anymore, so it's x plus 5. My denominator, however, can be simplified to x plus 4 over x plus 5. And if I have any common factors, I like to identify them early, like I do right there. All right, so going on, let's continue. And if those factors cancel out, then I'm left with x plus 5 divided by x plus 5 is 1 over x plus 4 remains in the denominator. So here's my little equation. To get my x-intercept, I have to make my numerator equal to 0. Well, my numerator is the number 1. I can't turn the number 1 and just say, you're a 0 now. So since 1 is not equal to 0, then I have no way of finding an x-intercept. So there is no x-intercept. What about a vertical asymptote then? That was the x-intercept. Vertical asymptote means take your denominator and make that equal to 0. I do have a denominator of x plus 4. To make that equal to 0, I get x equals negative 4. So there is one of my asymptotes. Now to figure out my horizontal asymptote, I have to use the degree or the exponents for my equation. The top has a degree of 1. The bottom has a degree of 2. 1 is less than 2. So according to my notes above, when the degree of P is less than degree of Q, then y equals 0 is my asymptote. So I'll go back and lock this down. Y equals 0 is my asymptote, and I'll go ahead and fill in those asymptotes now. So at x equals negative 4, 1, 2, 3, negative 4, I'll make an asymptote. At y equals 0, which is my x-axis, I have an asymptote. All right. Now, I don't know which way my graph's going to go yet, so let's look at the next piece of information, which is the hole. I do have a hole because I have a common factor. The common factor is x plus 5, which I identified above when I was factoring my equation. So I make that factor equal to 0. What number plus 5 would give me a 0? Well, that would be a negative 5. So I have an x value of negative 5. Take this negative 5 and plug it back into the simplified form of my equation for x, and I end up with 1 over negative 5 plus 4. 1 over negative 5 plus 4 is the same thing as 1 over negative 1. 1 divided by negative 1 is a negative 1. So I have a hole at negative 1, 2, 3, 4, 5, negative 1 right there. That identifies where my graph's going to be now. My graph's going to exist down here in this third quadrant, except at the hole. I kind of just skip over it. And then diagonally across up here towards the first quadrant. All right, so then my domain is every x value everywhere except at negative 4, where I have an asymptote, and also at negative 5, where I have that value, because remember, it's not equal to that. It doesn't have a meaning there, it doesn't exist there either. Same thing with my y values. I have y values everywhere except at 0 and at negative 1, because that whole means it doesn't exist there either. So those are 2 gaps for that example. Let's go on to number 5 now. Whoops, I didn't mean to make a line. Here we go. Number 5's example. Let me go ahead and get this locked down. Okay. So let's go ahead and begin by factoring the top and the bottom. The top has a leading coefficient that is greater than 1. But luckily I did my work in advance, And if we use our factoring rules, we get 2x plus 1 times x minus 1 on the top. In the denominator, when I factor, I get x minus 4, and then I get x plus 3. There are no common factors, so there should be no whole end. So I can fill that piece out right now. X-intercept. The x-intercept is anywhere your factors in the numerator equals 0. Well, I have two factors. I have 2x plus 1 equaling to 0, and then I have x minus 1 equaling to 0. Well, that means I'm going to have to do both of these separately. So what number minus 1 equals 0? Well, x would have to be a positive 1, so that one's easy. Let's solve this first one now. If I bring 1 to the other side, I get 2x equals negative 1. If I divide both sides by 2, then I get x equals negative 1/2. So there's my other one. So my two x-intercepts are at x equals negative 1/2, comma 0, and at positive x equals 1, comma 0. So negative 1/2, 0 is right here, and positive 1, 0 is right there. So my graph has to go through those 2 points at some time. Now to my vertical asymptote. That's wherever the denominator equals 0. And that one is also going to have 2 spots because there's 2 factors. The first factor I have is x minus 4. You make that equal to 0. The second factor I have is x plus 3. That's also going to equal 0. What number minus 4 equals 0? Well, that would have to be x equals positive 4. What number plus 3 equals 0? And that would have to be a negative 3. So I have 2 vertical asymptotes at x equals negative 3 and at x equals positive 4 because there was 2 factors. To get my horizontal asymptote, I have to look at the exponents of my original equation. The top exponent was a 2, the bottom one was also a 2. That means that they're both the same. When you have 2 that are the same, you have to use the leading coefficients. The top leading coefficient was 2, the bottom leading coefficient's a 1, 2 divided by 1 is 2, so there's my horizontal asymptote at y equals 2. Let's go ahead and fill these in now and get our graph. So we're going to have a couple of asymptotes. The vertical asymptote, we're going to have one at negative 3. So I go over to negative 1, 2, 3 on the x and make my first asymptote. Have another asymptote at x equals positive 4, 1, 2, 3, 4. And then I have my horizontal asymptote at y equals positive 2. All right, so I have 6 sections in this graph, and I have to make my curve. Well, I have the 2 points down here, so I get this parabola down here. And I have to find the other sections that are not directly adjacent. That means directly not left or right or up and down. That leaves this upper left-hand side and this upper right-hand side. They have to be diagonally opposite from the graph that I made. All right, so there's the graph, what it looks like generally. What's our domain? Well, our domain is every x value except where I have my my vertical intercepts at negative 3, and at 4. My y values are every value except where I have my horizontal asymptote at y equals positive 2. All right, so those are the 5 basic graphs. I believe we have some more coming up in the back, but it's all the same thing anyways. Number 6 is a special one that I did learn how to do, but I found out that's not going to be a huge requirement, so I will wait to show it to you if I even get to it at all. All right, so don't panic there, but here is the better video on day 25 notes. Your assignment will be given to you in class, so best of luck and feel free to ask any questions for any misunderstandings or if you need clarification, all right? Best of luck, guys.